Welcome to solverfy.
In this question, the planet gear A is pinned, connected to the end of link BC. Okay, so this is the planet gear A, and then we have the sun gear D. Okay, yeah, and omega BC is rotating about fixed point B at 4 radians per second. We need to determine the angular velocity of the ring gear R in this question. And in this question, we are given that gear D is fixed from rotating. Okay, so what does that mean? Is that, so say here, this point, the speed will be 0. This point, the speed will be 0. Okay. Yeah, the point where gear D is in contact with other objects will have 0 speed. Okay. So points that gear D contact with gears A and R have 0 speed. Okay. Okay, so when it comes to gear A, okay, so for gear A, if you draw gear A, you have C is this point, and then this point I'm going to call it E, okay, which is here, E. Okay, so from the diagram we expect BC will be pointing up because of the rotation of the link BC, and then VE will also be pointing up in this way. Okay. Right, so we can calculate VC. Okay, VC is equal to omega BC, RBC. Okay, so this is equal to 4 times 0.225 meters. So we get 0.9 meters per second. Okay, then so VE will be twice VC. Okay, if you calculate from IC, so this is 1.8 meters per second. Okay, then when it comes to gear R, okay, so this is omega S. Okay, gear R, no, this is gear A, omega A. Okay, okay, then when you have gear R, so gear R is bigger. Okay, and then we have this point E that is moving at VE equals to 1.8 meters per second. Okay, and then it has this counterclockwise angular velocity. So and then we also have the IC to be here. Okay, this is the point where it touches the sun gear D. Okay, then omega R will be VE divided by RIC to E. Okay, so this is point E. Okay, so based on the diagram, so the radius of A is 75 mm, the radius of D is 150 mm. So from IC to E would be 450 mm. Okay. Yeah, so we have 1.8 divided by 0.45 meters, we get 4 radians per second. Okay, so this is the answer for this question. That's all.